In this lesson, you will learn how labels can impact query performance and how to refactor a graph to add labels. Node labels serve as an anchor point for a query. By specifying a label, we are specifying a subset of one or more nodes with which to start a query. Using a label helps to reduce the amount of data that is retrieved. For example, this query returns all nodes in the graph, and this query returns all person nodes in the graph. Your goal in modeling should be to reduce the size of the graph that is touched by a query. In Cipher, you can produce a query plan that shows what operations occur during the query. This figure shows a query plan by the number of dB hits for the query to retrieve all person nodes. Later in this lesson, you will learn how to produce a query plan. If person nodes also has a label, which is the country that a person is from, then you could use this cipher code to retrieve all people from the US. It returns all US nodes in the graph, which happen to also be person nodes. But having a label that is specific like this might be overkill, especially if the query could be the following. In Cipher, you cannot parameterize labels, so keeping the country as a property makes the Cipher code more flexible. But if you have a strong use case for having multiple labels for a node, you should do so. You should use labels wisely in your data model. They should be used if it will help with most of your use cases. A best practice is to limit the number of labels for a node to 4. Here is an example of overuse of labels in the data model. Here we see person nodes that have a label representing the country that a person is from, like we described earlier. In addition, we see multiple labels for movie nodes. The label represents the languages available for a movie. This is another similar scenario where you might decide if an important use case is related to the language of a movie. Again, if the use of a property for a node will suffice, then it is best not to have the label. Here is an example where adding a label will help our queries at runtime. We have a new use case. What actors were born before 1950? Here is the Cipher query to test this use case. And here is what the query does. A node by label scan to retrieve all person nodes. It tests the born property for the nodes retrieved to filter them. Then it determines which of these filtered nodes have the outgoing acted-in relationship. And finally, it returns the name property values. You can use the profile keyword to see the performance for a query. Here is a result of the profile. Because the cache is automatically populated, it is sometimes hard to measure performance with a small data set. That is, dB hits and elapsed time may not be comparable. What you can see, however, is the number of rows that are retrieved in the query, and this number can be compared. In the first step of this query, we see that 5 rows are returned. You can imagine that if this query were a fully loaded graph with millions of nodes in step 1, it would need to retrieve a lot of person nodes, some of which are not actors. One way that you can optimize its retrieval is to change the data model to include an actor label for a person node. If we refactor, the initial node by label scan would only retrieve the actor nodes. Here is the instance model we will refactor in the graph. With Cipher, you can easily transform the graph. With this code that you will execute in the next challenge, we find all person nodes that have an acted-in relationship. Then we set a label for the node. In the next challenge, you will refactor the graph to add actor labels to the nodes. This completes our look at how labels can impact query performance and how to refactor a graph to add labels.